Hypothalamus Artificial Intelligence, HI. A new way of thinking about business administration, which will change the world as we know it. Presents the vision about artificial business management, using enterprise-wide optimization systems that are based on artificial entrepreneurial brains. Human intelligence has evolved along with human beings. From an incipient basic intelligence, in the origins of human beings, that needed to see to believe, to a highly developed intelligence, with intuitive scientific ability, which can mathematically predict the behavior of the universe, without having to perform verification experiments. This is the case of Einstein, who, after experimentally demonstrating the theory of relativity, developed multiple theories that history was responsible for demonstrating. To understand this process, HI describes human intelligence as composed of three intelligences. Mental intelligence, basic to all human beings, oriented to the recognition of patterns, without an understanding of why it identifies them. Mathematical intelligence, which is developed by trying to understand why these patterns occur, to explain behavior in the real world. It's not innate, it requires math, starting with algebra, all the way up to parallel math, which today's big computers require. It focuses on scientific decision-making. Many humans never develop it. Creative intelligence. It is developed by privileged human beings, who learn to use mathematics to create the theories that are required for the humans to move their mathematical intelligence. Very few humans develop it. Artificial business management. Artificial intelligence robot Mika is the leader of the luxury liquor company, Dictator, based in Poland. Dictator has signed a contract with Mika, who now sits on its board of directors, and holds the position of CEO. Enterprise-wide optimization will be the artificial hypothalamus of the robots that run companies. It's the future that awaits us. Enterprise-wide optimization systems. HI, thanks to its peculiar vision of mathematical modeling, which is not based on computer programs, but on a relational database, which is used by a generative artificial intelligence that interprets the database, and produces all the necessary computational code, can quickly implement what Professor Jeremy Shapiro called enterprise-wide optimization. In line with HI's vision, enterprise-wide optimization systems are the evolution of traditional decision support systems, which have accumulated several mathematical models, many of them without following a standard, which ensures consistency across all models. These models run independently of each other, and are usually coordinated by a database, or multiple databases, that integrate the input-output. While each model can ensure optimality, this approach is not optimal, as there is no company-wide model. The offer presented by HI is based on the vision of the so-called enterprise-wide optimization, EWO, that is an emerging area that sits at the interface of industrial processes and intensive operations research. Due to the advent of Industry 4.0, it has become a major target in process industries due to the pressures to remain competitive in the global market. EWO involves optimizing a company's core operations, sourcing, manufacturing, distribution, and financial activities, to maximize its economic utility from a holistic point of view, and not through separate silos, with weak connectivity between them. This, coupled with global pressure for sustainable industries that have environmental aspects in mind, such as the clean production of the energy they consume. One of the key features of EWO will be the integration of information and decision-making between the various functions that make up an industrial supply chain. This can be achieved with modern computing tools, cloud and edge computing, which together with the Internet of Things, IoT, have promoted e-commerce. To fully realize the potential of EWO, the development of sophisticated optimization models and algorithms, analytical IT tools, is needed for optimal overall economic performance, as well as high levels of customer satisfaction. An additional challenge is integrated and coordinated decision-making between the various functions of a company: purchasing, manufacturing, distribution, sales, human resources, maintenance, energy management, etc., across several geographically distributed organizations, suppliers, facilities, markets, etc., and across various levels of decision-making: strategic, tactical, and operational. HI's vision, developed in practice over more than 35 years, has allowed HI to evolve from decision support systems, conceived as the chaining of algebraic equations, to the chaining of pre-formulated problems, to build a super decision-making system, as a Lego game. Under this vision, it has developed the proposal of mathematical models that can be part of AWO. High models mainly support two types of industrial planning activities. S&OP, sales and operations planning activities that are carried out periodically, usually every month or every week, to coordinate the selling products with production activities. IBP, integrated business planning, activities that are carried out periodically, usually every 6 months or every year, and aim to perform integrated value chain of the organization planning. In 2006, Jeremy Shapiro published the article Beyond Supply Chain Optimization to Enterprise Optimization, in which he stated, "The recognition that strategic supply chain planning should be integrated into larger business planning exercises will serve to break down barriers to fact-based decision-making. Starting from SCM or supply chain management, focused on production, as a first step in standardized planning." Shapiro envisions what the S&OP, sales and operations planning model, formally is, as the integration of sales and production planning. And finally, he establishes what is now IBP, integrated business planning model, which involves the financial planning as enterprise planning. That implies the incorporation of ALM models, assets and liabilities management, as part of supply chain planning. Until the advent of Industry 4.0, S&OP modeling was concentrated on production modeling. Considering as parameters exogenous, the result of models for sales and maintenance. The financial results are obtained from a post-processing, in some cases in Excel books. In the ERA of Industry 4.0, S&OP may be constructed based on 8 groups of solutions or systems: production, energy, maintenance, distribution, sourcing, human resources, financial, and sales and marketing. I view the systems as groups of equations that must be included in the S&OP mathematical problem depends on many factors, so that there is no revealed truth regarding what the S&OP problem is. Since the equations are defined in a database, the configuration of a problem is limited to selecting from the equation store which are the ones that the modeler wants to consider in the model. Visually, it is easy to see the evolution of the traditional S&OP concept to a modern IBP, that covers, virtually, all the operational functions of an industrial organization. This leads to two problems that must be solved from a computational point of view. If traditional approaches are used, a large number of programmers are required to generate all the necessary source code, and to coordinate all the models, and large computational power is necessary to solve the integrated problem. This evolution gives rise to enterprise-wide optimization. Enterprise-wide optimization, the comprehensive and complete view of the value chain, improves competitive advantage, reduces costs and increases profits. Therefore, managers seek to comprehensively optimize the planning and scheduling activities of their value chain, which was originally understood as the coordinated sum of supply chain management, SCM, and demand chain management. Today, AWO has expanded and covers all functional areas of the organization, including financial and human resources chains. There are 4 dimensions to the optimal synchronization of a supply chain, namely: functional associated with the purchase, manufacture, transport and storage of industrial inputs and products; spatial associated with activities through industrial facilities and different forms of markets; hierarchical, associated with the impact of decisions, strategic, tactical and operational; and business. Enterprise integration makes SCM one of the components of a broader view of integrated planning. They respond to the purposes of strategic and tactical planning within the organization. OPTEX, the expert system for optimization, is used as the way to develop and implement AWO solutions, in which multiple mathematical models converge, and can be connected via a disk or cache databases, to form a monolithic model of the enterprise. OPTEX is the generative artificial intelligence produced by HI, which manufactures optimization systems for the entire company, according to the state-of-the-art of Industry 4.0. Created in 1991, OPTEX has been used by HI in the implementation of multiple AWO systems, and according to the knowledge of the HI, is the only computer tool capable of integrating hundreds, if not thousands, of mathematical models, running on a parallel and distributed computer system. For those interested in learning more about OPTEX, HI invites you to watch the video OPTEX, Optimization Expert System. Making an enterprise-wide optimization system, integrating multiple large-scale models, using a computer programmer, is an impossible approach, because the programmer can only write a limited number of lines of good source code per period. Maintaining these models can be more complicated than making them, if there is more than one programmer involved in the process. Only a generative artificial intelligence can produce infinite lines of perfect source code in seconds. OPTEX, Optimization Expert Systems, is oriented to the decision-making artificial intelligence methodologies and technologies that make mathematical models as Lego models. OPTEX was created in 1991. OPTEX is a generative artificial intelligence focused on the design, implementation, startup, and maintenance of artificial brains, based on high-complexity mathematical models. The way the mathematical modeler communicates with OPTEX is through a standardized database, a unique data model for all mathematical problems or subproblems. This method is called structured mathematical modeling. It also allows to perform high-level operations between models, such as joining or splitting them, and implementing multi-problem solutions, according to large-scale optimization technologies, or using multi-problem procedures, such as constructing optimal numerical functions. Joining, or splitting models, is done by keeping records in tables. In other words, in practice, to date making a model in OPTEX is to select the equations that make it up. The models are built in a modular way, as if they were a Lego set, which are formed by a compatible system of equations, Lego parts, for all models. Artificial brains, integration of artificial intelligence and mathematical programming, are the result of HI's research in disruptive mathematical modeling methodologies for Industry 4.0. And they are the basis of the computational architecture of the enterprise-wide optimization systems. For more information, those interested are invited to watch the video. Artificial brains, artificial intelligence and mathematical programming integration. The R+D project focuses on enabling professionals, who are not experts in mathematical modeling, to build highly complex mathematical models, using the mathematical models stored in an OPTEX expert system. To do this, GPT methodologies will be used, so that the development of a model can be carried out through a chat, and later through a conversation. OPTEX GPT will become a cloud platform, by incorporating public models into the database, which will ultimately turn OPTEX GPT into a service for companies and professionals who want to implement mathematical models on the fly. OPTEX GPT will be your interactive artificial intelligence, advising you on how to make highly complex mathematical models, without the need for computer programming. Like Herbert Simon, Hypothalamus AI believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.